Greetings. In this video, I'm going to present our paper, a semiotics-based epistemic tool to reason about ethical issues in digital technology design and development. It was co-authored by Professor Simone Barbosa, Clarice de Souza, Carla Leitão, and myself, Gabriel Barbosa, a master's student in data science at PUC-Rio. When building computational artifacts, designers inscribe their own subjective meanings into them, which can in turn create ethical issues that scale greatly for information technology use. Even the most minute decisions can scale and have significant impacts. It just so happens that designers often don't fully recognize their agency over the situation and their moral responsibility towards the technology's consumer. This is a point that Kuckelberg brings up in his 2011 paper, in which he proposes that we move on from focusing on individual agents' actions and start looking at the relational nature of development, with technology producers being the agents and technology consumers being the patients. In this work, we propose a tool based on the theory of semiotic engineering that focuses on the epistemic processes involved in the design and development of computational artifacts, with an emphasis on ethical considerations. At this point, we have conceptualized the tool and analyzed its coherence and cohesion. Our goal is to expose the tool in its conceptual stage to interdisciplinary debate. Once it has been thoroughly discussed, we can move on to empirical evaluation, with the discussions also helping to inform what information we look for. So what is semiotic engineering? It started as a theory of human-computer interaction that considers computation as a form of computer-mediated communication between users and designers. At use time, the designer will not be present, but their intent will be inscribed into the system itself, serving as a form of deputy for them. At a top level, designers send a meta-communication message to the user, telling them how they should interact with the artifact. So while interacting with the system, users are engaging in a meta-communicative process that can be represented in an abstract top-level meta-communication template, which is structured as, here's my understanding of who you are, what I've learned you want or need to do, in which preferred ways, and why. This is the system that I have therefore designed for you, and this is the way you can or should use it in order to fulfill a range of purposes that fall within this vision. The template mentions the designer's understanding of the problem and stakeholders and describes their ideas of what the final product should be. There are a few key things about the template that are worth noting. First, it frames the meta-communication message in the first person, from the perspective of the designer, and the second person addressing the user. This directly highlights the relational nature of communication. It also expresses design intent through natural language, which requires designers to consider the words they use to communicate with their users. They would need to choose the right words, which requires them to have a clear conception of what the artifact should be, as well as having to structure their thoughts. Conscious use of language to express their intent then serves an epistemic purpose, since it requires an individual to consider their existing understanding and to organize any knowledge they seek to communicate. Tying it all together, we can start with the recognition that issues of moral responsibility are relational in nature. They usually focus on relations with agents acting upon patients. As we have seen, semiotic engineering establishes an explicit relationship between the system's designer, who would be the agent, and its users and stakeholders, who would be the patients. Designers are asked how they would communicate their design intent to users, having to consider whether they are able to receive the message and comprehend it. This process also allows for greater empathy between the designer and end users. Marcos, Cat, and Goodyear, in their 2017 book, argued that nowadays professionals need to perform constant epistemic activity in their practice. They not only need to consider what they know, but also how they can consciously acquire and organize even more knowledge. Semiotic engineering tools are built with epistemic purposes in mind. They allow for situated knowledge construction and organization, due to its focus on natural language and meaning. Considering the meta-communication template allows for professionals to not only gain insight into the situation they're intervening in, but also to gain expert knowledge that can be applied in different contexts. In this work, we propose an extension of the meta-communication template with an explicit focus on ethical and moral responsibility. Our tool is based on a set of guiding questions about the designer's intent, which seek to help them organize the meaning and form of their meta-communication message. The resulting message could then be analyzed in terms of its emission by the designer and reception by the user through existing methods in semiotic engineering, such as the semiotic inspection method and the communicability evaluation method. So in terms of the tool itself, The question's main goal is to lead designers towards a structured meta-communication message. They can be classified into base design questions, which focus on the designer's intent, and ethical questions, which ask them to backtrack to their previous design choices and consider their ethical connotations. All of the questions explicitly frame the designer in the first person and the user in the second person, highlighting the designer's agency and the relational nature of their design. These guiding questions are split into 4 stages, following a traditional design process of analyzing the problem, designing a solution, prototyping and implementing it, and monitoring and evaluating it after deployment. The meta-communication message can also be split into these stages, as shown in the diagram. At the end of each stage, there are ethical questions that ask the designer to revisit their previous answers to the base design questions, focusing on their ethical connotations. In order to help them reflect on these issues, the questions can also be supported by different ethical frameworks, such as the bioethical principles or virtue and utilitarian ethics. These frameworks are meant to provide different ways for the user to frame their design choices and explore their possible consequences. Of course, they can also rely on their own personal principles. At the analysis stage, we focus on the designer's understanding of the problem domain. In terms of design questions, designers should ask themselves what they know about the user, stakeholders, and the context in which they intend or anticipate that the tool will be used. The ethical question asks designers to revisit what they know or do not know and try and identify any ethical issues. In order to illustrate how these questions would be used, let us imagine we are developing a system that connects service providers with service contractors. We will focus specifically on the feedback that contractors can give on services provided. In terms of what we would know or not know, we can mention our uncertainty on how much feedback a service contractor would be willing to give. The simple gap in our knowledge can indicate to us that we do not fully understand how they may perceive the effect that their feedback would have. They might, for instance, purposely misrepresent their opinion to try and influence events. We can notice that this entire point revolves around the meaning of feedback. Our understanding of it as designers may be different from the users. This, in turn, can lead them to believe that it works differently than it actually does, causing confusion and inappropriate usage. At the design stage, we focus on the conceptual solution to the problem. In terms of design questions, designers should ask themselves what they are building, which goals it supports, in which situations it should or could be used, how it should be used, and for what purposes it should not be. The ethical questions ask them to revisit the principles behind their decisions and how what they are building aligns with them. In our example, we could state that the system was designed to allow contractors to provide feedback on services rendered. During the ethical reflection questions, when asked about our principles, we could argue that feedback could help improve services and benefit future contractors. By contrast, we could also state that we consider a lack of feedback as indicative of a problem. Our design then aligns with these principles by allowing contractors to give feedback or skip it if they wish. We can observe that we try to frame feedback as positive, perhaps as a justification for our desire to collect it. Its lack would then be a negative thing for us, since we may want to use it to determine how many requests a provider gets. At the prototyping and implementation stage, we focus on the process of implementing our conceptual design. Here, in terms of base questions, designers should ask themselves about how they built their system, what they did to avoid undesirable uses, and what they did to help identify unanticipated negative effects. The ethical question then provokes them to reflect on the scenarios they imagined when building the system itself. Going back to our example, we could state that we had built a feedback system looking to help us decide whether or not providers get any future requests. In terms of ethical scenarios, we could conceive of a situation where the service contractor tries to use the rating system to harm service providers, based on an assumption that it will be effective. Given our design statements, they would be able to. In this part of the example, we're faced with the amount of agency we give contractors over providers. Given that we may want to use the feedback data to determine how many requests a provider gets, contractors can use this system in a harmful way, whether they intend to or not. The provider, on the other hand, would have no equivalent recourse, making it an unfair situation. The final stage in our tool is concerned with the post-deployment process. In its base questions, designers should ask themselves about how much of their expectations actually came true, and which unanticipated uses and effects were made. The final ethical question asks us, as designers, to consider how any ethical issues we identified should be handled. It specifically mentions the possibility of redesigning or redeveloping the system, making policy changes, or even decommissioning the system as a whole. Finishing up our example, we could identify that the rating system was seldom used. In this case, there would be a possibility that we considered this lack of rating as an indication that service providers had done a poor job. This might negatively affect the number of requests they receive and their livelihood. In order to try and fix this, we could propose a system redesign that makes it easier to give feedback. Note that we do not challenge the notion that a lack of feedback should be considered as indicative of poor service. This in and of itself can tell us about our own priorities when critically analyzed. These limited examples provide only a small set of possible answers to these questions. A more complete illustration can be found in our paper. In reality, most software development tends to involve teams of designers, developers, and other professionals. The presence of multiple individuals can make it difficult to ascertain who is responsible for what aspect of the system. Thompson identified this issue back in the 80s within the context of policymaking, where attributing individual responsibility would be difficult given the various contributions made. The same can occur in software development. We propose that this distributed view of the product could be turned into more of a collective view of the system. Members of the development team would express their perspectives on the solution and would then engage in a process of meaning negotiation. As they get closer to a collective view of the artifact, more responsibility will be more uniformly shared, as members of the team would have a similar understanding as to what the final solution should be. This diagram illustrates one possibility as to how this process could occur. From speaking with separate voices, the development team would start negotiating and agreeing on what the artifact should be, starting to speak with a more collective voice. As they start to develop the shared view of the solution, it will be as if the team was communicating with a singular voice through a single meta-communication message. Now let us discuss our own experiences with the tool. In our paper, we present a more robust example as to how one would go about answering these guiding questions. During the process of building this example, we also tried to analyze our own subjective experiences with the tool, focusing specifically on its epistemic properties. The first thing we noticed was how difficult it was to find the right words to express our view of the artifact. This forced us to recognize the subjective meanings that we were inscribing into it, and now had to communicate to the user. By critically analyzing the resulting message, we were also able to detect ways in which the solution we were proposing did not match our intentions, as expressed through the text. This could indicate a lack of clarity on the subject, as we were unable to accurately communicate it. Having to express these ideas in a meta-communication message, we were then faced with the presuppositions behind our own decisions. Any statements we made would provoke us to reflect on their basis, which may or may not have been solid. Critical analysis of the text allowed us to not only gain insights over the solutions we were proposing, but also into our own modes of thinking. The way we framed our message was key here. If we were overly positive on some aspect to the point that we were later able to detect it, it would indicate to us that there was probably some issue we were overlooking. Another interesting point was that what we did not write said as much about our design as what we did write. Looking at the gaps in the message proved to be as informative as looking at the actual information included in it. Having committed to the first-person perspective, we were also forced to recognize our own agency. Every design decision would be attributed to us. Furthermore, the relational nature would also be apparent, as we would have to acknowledge that these choices would affect the you of the matter, the end user. Committing to this perspective was not trivial. Some statements were so sensitive that we caught ourselves trying to distance from them. We would attribute certain actions to the system, when they were in fact based on our own choices. Noticing where we tried to avoid this perspective was valuable in telling us what aspects of our design we were sensitive about. Answering these questions also caused us to double back many times. Utterances in the design stage, for instance, would make it clear that we were missing some information about the problem domain. We would then have to go back to the analysis stage and consider how to get it. We were also forced to double back at the end of each section to consider the ethical issues involved. When first going through a certain stage, we would be free to just consider the design aspects. Having reached the ethical questions, we would then revisit these statements, looking at what they were communicating and the ethical issues they implied. On a first pass-through, we would act as emitters of the message, and on a second one, as the receivers of it. Changes to various utterances would also cause ripple effects, leading us to reconsider previous statements. These would also cross domains with ethical utterances, leading us to revisit design statements and vice versa. In building this tool, we also drew inspiration from various related work. Our decision to follow the first-person perspective was inspired by Brown's consequence scanning and O'Boyle's decision-making process questions. Several heuristic-oriented approaches influenced the aspects of the design and development process that we considered in our questions. Another relevant inspiration was Harris and colleagues' Diode, a meta-methodology for ethically assessing new technologies. Our solution has a different focus, however, looking at the epistemic processes involved in the design and development process. We also drew inspiration from other existing tools that make use of statements and descriptions of data and models, such as Gabriel and colleagues' datasheets for datasets and Mitchell and colleagues' model cars for model reporting. As for future work, we mostly plan to empirically evaluate the tool in its current state in order to gain a better understanding of how these epistemic processes manifest themselves in real use. The first possibility would be to conduct case studies with professional developers in real development situations. We also plan on evaluating the applicability of different ethical frameworks with the tool. In our example, we've used the bioethical principles. What would have happened if we'd used virtue ethics, for instance? A more long-term study would be to investigate the evolution and persistence of the epistemic processes during the entire life cycle of a project. How do the designer's perspectives on the solution change as time goes on? How does the tool affect this process? With these future studies, we seek to further investigate how our extension of the meta-communication template can help professionals not only reflect on specific design projects, but also gain expert knowledge that can be used throughout their careers. This has been a presentation on our paper, a Semiotics-Based Epistemic Tool to Reason About Ethical Issues in Digital Technology Design and Development for FAccT 2021. Thank you for watching.